Alright, so today's lesson is Chapter 8, Lesson 7, which is Solve One-Step Inequalities. Okay? So for the warm-up, we want to use the graph of the inequality shown here, and we want to write an inequality for that graph. Okay? So when we look at that, graph, we have to look at what side the line is shaded on, right? We also have to look at what kind of circle there is, and we need to look at what's the important number, okay? So, when we look at the number line, what side are we shaded on? We're shaded on the right-hand side. So, is that going to be a greater than or a less than? That is going to be a greater than. Shaded on the right-hand side, it's going to be a greater than. Greater than what? What's the important number? 5. So it's going to be greater than 5. Is everybody with me? Now, and you can use whatever variable you want. So, we've got, let's just use x, is greater than 5. Now, more specifically, okay, when we look at the symbol, what kind of circle do we have there? It's an open circle. So, is that going to be a greater than or a greater than or equal to? Just a greater than. Very good. So that our inequality is correct. Okay, so we have x is greater than 5. So now, number 2 says, which one of the following inequalities have the solution shown on that number line? Okay, so we want to know what solution, if any of these inequalities have this x is greater than 5, have the same solution. Okay? So, anybody remember how do we decide if a number is a solution for an inequality? So yes, we are going to evaluate and then compare. Okay? So we're going to substitute, simplify, and then compare. Okay? Now, how do I choose which number to put into the inequality for the variable? It can be any number from this inequality up here. X is greater than 5. So I can choose, what can x be? 6, 7, 8, 9, and so forth, right? It can be any of those numbers. So let's write this down. So it can be any of those, x can be any of those numbers, right? So we'll just pick one and then put it into the given inequality. So let's choose, for the first one, let's choose 6. Okay. So let's choose 6. So we have 6 plus 3 is less than 8. So we substitute. Now we simplify. 6 plus 3 is 9 is less than 8. Is that true or false? That is false. So that does not have the same solution. Alright, so let's choose 7. We choose 7 now? Alright, you choose whatever you want, right? You could even choose 6 again. Okay? So here, 7 plus 1 is greater than 6. So 7 plus 1 is? 8 is greater than 6. Is that true? Yes. So this is a solution. Alright, so let's choose 8. So we've got 8 minus 4 is greater than 1. So 4 is greater than 1. Does it have the same solution? Yes. That is a true statement. And then finally here for letters, for C, what do you want to choose for that? Okay, let's choose, we can choose anything we want.
25.
21. 121. Let's just choose 9. So 9 minus 7 is greater than 12. So 9 minus 7 is 2. Is that greater than 12? No. No, that is not. Alright, so now we are going to use addition and subtraction properties to solve inequalities. You guys remember what the addition and subtraction properties of equality are? If you add on one side, you have to add on the other side. If you subtract on one side, you have to subtract on the other side. Those are the subtraction and addition properties of equality. Well, those properties are also true for inequalities. Okay? So make sure you write this part down. When you add or subtract the same number from each side of an inequality, the inequality remains true. Okay? So here we have 5 is less than 9. If I add 4 on both sides, that's the addition property of equality. If I add 4 on both sides, we'll end up with 9 is less than 13. 9 is less than 13. That's still going to be a true statement. Is everybody clear with that? All right. Same thing with 11 is greater than 6. 11 is greater than 6. That's true. If I subtract 3 on both sides, my new inequality will say 8 is greater than 3. That is still a true statement. So for example 1, we are going to solve x plus 7 is greater than or equal to 10. And we want to graph it on the number line. So when we are solving, remember we're going to use our cover-up, right? So we're going to cover up what we're solving for. So we're going to cover up, and I'll do like this. We're going to cover up x. Oops. What does that mean I need to get rid of? The 7. Very good. I need to get rid of the 7. So in order to get rid of the 7, because it says plus 7, we're going to subtract 7. Okay? So when we subtract 7, those cancel out. Please make sure you're showing your canceling. And then x is greater than or equal to 3. So now we're going to graph. Okay? So, what's the important number? 3. The important number there is 3. What kind of circle am I going to have at 3? You're going to have a closed circle. Very good. So the important number was 3. We are going to have a closed circle at 3. And I'm also going to look at that symbol to tell me which way I'm shading. Which way am I shading? To the right. Because it's greater than, right? So this is what your graph will look like. So our important number is 3. We have a closed circle at 3, and we're shading to the right. So, for example 2, we want to solve and graph x minus 3 is less than 9. So once again, we're going to use our cover-up. So we're going to cover up the x. Whoops. Cover up the x. And what does that mean we need to get rid of? The minus 3. So in order to get rid of the subtract 3, we want to add 3. Very good. So we're going to add 3 on both sides. Those 3's will cancel. And we end up with x is less than 12. Now we want to graph it. And again, we're going to ask ourselves the same questions. What's the important number? 12. The important number is 12. Okay? What kind of circle am I going to have at 12? Open circle. We're going to have an open circle. And which way are we going to shade? We're going to shade to the left. Very good. So this is what your graph looks like. You have an open circle and your important number, which is 12. And because it says less than 12, x is less than 12, we're graphing for shading to the left. All right. So for the got it problem A, we want to solve and graph n plus 2 is less than or equal to 5. So we're just going to, when we're solving, we're going to cover up our variable. So what does that mean we need to get rid of? Plus 2. A plus 2. How are we going to do that? Subtract 2. Very good. So we're going to subtract 2 on both sides. The positive 2 and negative 2, those cancel each other out to 0. And what are we left with? N is less than or equal to 3. Very good. So when you're doing your number line, you guys, I'm going to say you don't have to put every single number. You don't have to put tons of numbers on your number line. I'm going to tell you that you just write your important number and then one or two on this side and one or two on that side. Okay? On either side of the important number. So here, what's our important number? 3. Let's just write this down. This is the important number, right? That's our important number. So our important number is 3. Okay? How do I decide what kind of circle I'm going to have? We're going to look at our less than or greater than, right? So this one is a less than or equal to, so what kind of circle are we going to have? That's going to be a closed circle. Very good. So we're going to look at our symbol to determine what kind of circle we're going to have. Okay, and we said we're going to have a closed circle because it's less than or equal to. And then it also tells us the direction of the shading. And again, because it's less than, which way are we going to shade? Left or right? To the left, because it's less than. Very good. So now we can graph. Now we have all that information from our inequality, now we can graph. So the important number is 3. We have a closed circle at 3, and we are shading on the less than side, so that's going to be on the left. Is everybody clear with that? All right. All right. So for example B, let's do that one. We've got y minus 3 is greater than 9. So the first thing we want to do is we want to solve the inequality. And remember, when we solve the inequalities, it's just like solving an equation. So here, how am I going to get that y by itself? We're going to add 3, because that says subtract 3. We're going to add 3 on both sides. So here, the positive and negative 3 cancel out to 0. And we end up with y is greater than 12. Very good. So our important number is 12. What kind of circle are we going to have at 12? Open. And which way are we shading on the number line? Y is greater than 12, so we're shading to the right. Very good. So now we want to use multiplication and division properties of equality to solve inequalities. Please make sure you write down your heading. So we want to use multiplication and division properties to solve inequalities. Now, make sure you write down this rule, okay? When you multiply or divide each side of an inequality by the same positive number, the inequality remains the same. Okay, make sure you write that down. Okay, I circled positive because something different happens when we multiply or divide by a negative, and we'll get into that later. Okay, so when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So for example, here we have 5 is less than 10. That's a true statement. If I multiply both sides by the same positive number, multiply times 2, we end up 10 is less than 20. The inequality is still true. Okay? Same thing with division. Here we have 16 is greater than 12. If I divide both sides by the same positive number, divide by 2, we end up with 8 is greater than 6. 8 is greater than 6, that is still a true inequality, true statement. So for example, we have 5x is less than or equal to 45. So we want to solve that, and we want to graph it on the number line. So because it says 5 times x, of course, the inverse of multiplication is division. So we're going to divide by 5 on both sides. So when we divide by 5, these 5's cancel to 1's. So 1 times x is x. And we end up with x is less than or equal to 9. Okay? The important number is 9. Here's my important number 9. The important number is 9. This symbol tells me that we're going to have a closed circle at 9 and that we're going to shade to the left. So this is what our inequality looks like. Our graph looks like. Same thing when we have a division inequality. Here we have x divided by 8 is greater than 3. To solve for x, we're going to multiply times 8 on both sides. We end up with x is greater than 24. Here, the important number is 24. The symbol, the inequality symbol, tells me that I'm going to have an open circle at 24. And it also tells me, because x is greater than 24, we're shading to the right. So this is what our graph looks like of the inequality. So, for guided example, our problem number, letter C, we have 10x is less than 80. 10x is less than 80. So to get the x by itself, we're going to divide. Very good. We're going to divide both sides by 10. The 10's cancel to 1. So 1 times x is x. So we end up with x is less than 8. Okay? So our important number is what? 8. What kind of circle am I going to have at 8? Open circle. So open circle at 8. And which way are we shading on the number line? It's less than 8, so we're going to the left. Very good. And that's all there is to it. So for problem D, we have x divided by 6 is greater than or equal to 7. So to get that x by itself, because it's division, we're going to multiply. Very good. So we're going to multiply both sides by 6. Remember how we show our work. Here, the 6's cancel to 1. So we have 1 times x is x is greater than or equal to, and 7 times 6 is 42. Very good. So the important number is 42. What kind of circle are we going to have at 42? Closed circle. Very good. So we'll have a closed circle at 42. And which way are we going to graph? Shade. We're going to shade to the right. Alright, so for example 5, it says Laverne is making bags of party favors for each of the 7 friends attending her birthday party. She does not want to spend more than $42 on the party favors. Write and solve an inequality to find the maximum cost for each party favor bag. Okay? So, the first thing we want to do is look at the words. What's the important words in here? Well, it says here, right, she wants to make party favors for each of her 7 friends. Okay? What operation is it going to be? What word tells me the operation? For each, that tells me we're going to multiply. Very good. So we're going to multiply the cost of each one of the party favors times the 7 friends. So that's my 7C, right? Now, looking at some more important information in here, it says she does not want to spend more than $42. She does not want to spend more than $42. So, what inequality is that? It's going to be less, right? Because she doesn't want to do more. But can she spend 42? Yes. So that's going to give me the less than or equal to. Is everybody clear how we got that inequality? Yes. Okay. So now we can solve it. So 7C is less than or equal to 42. We're going to divide by 7 on both sides. And the cost of each one of those party favors is going to be less than or equal to $6.